So in a compressor we have to input certain work, and then of course we will have a fluid that enters at a certain pressure and will exit at another pressure. But in this case, the main difference between the compressor and the pump is that the compressor has to have an input of gas and an output of gas. The mass balance for this guy will state that area 1 velocity 1 over specific volume 1 equals area 2 velocity 2 over specific volume 2. And in this case, in the gas, the specific volume will change. So that's one difference. And the energy balance, or the first law, will state, for instance, that delta W plus delta Q plus delta H. Now it is relevant for us to put an H because U plus PV, in this case, the term of delta U will not cancel, plus delta K, which is the kinetic energy, plus delta potential energy will be equal to 0. And it could happen that we have a loss of heat. It could happen, but for the means of this video, we can say that there is no loss of heat, that the change in kinetic energy is negligible, and that the potential energy change is negligible. So at the very end, the work you need to input is going to be equal to the change on the enthalpy of the gas. Well, you can actually add, for instance, here the heat that is going to be lost. So if there is heat lost, then you have to input even more work to the system. And yes, if you have to change the kinetic energy, then you have to add it, but usually that's negligible. So this will be, for instance, the energy balance of the compressor. This is how you can obtain the work for a compressor. And then we have, for instance, a turbine, and the story is very similar, but in this case, in the turbine, what is going to happen is that you have to input a gas that is usually overheated, and then you are going to exhaust this gas in order to get a useful work. For instance, that is what happens in the turbine. The mass balance in the turbine is going to be exactly the same. Area 1 velocity 1 over specific volume 1 equals area 2 velocity 2 over specific volume 2. And the energy balance will be kind of the same, delta W plus delta Q plus delta H plus delta K plus delta potential energy equals 0, where delta K and delta potential energy can be negligible, and for instance the work that you're going to have is going to be equal to delta H, in this case minus the heat that you might actually lose. But usually you say that the work out equals the change in enthalpy in this case. So the story is kind of the same. The main difference between the compressor and the turbine, well, of course, the compressor you need work to change the enthalpic state of the gas, while in the turbine you are going to change the enthalpic state in order to get a useful work.